Hello everyone. In this video I would like to briefly discuss binary and how it works in order to give you more support and more context in this particular topic. So before we can even start binary, what we have to do is we have to look at decimal or denary. This is the number system that we use normally in maths. You'll all be used to it and you don't even think about it when you're using it. And there's a reason why I'm going to show you how decimal works. And hopefully it'll make sense when we look at binary. So decimal is our number system that we use every day, also called denary. I believe it is Arabic or Indian in origin, and the reason it is called decimal is because of dec, which is a Latin or Greek word I believe, and it means 10. The reason why this is the case is because we have 10 symbols in decimal. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the symbols that we use to write every number that we can think of. You can think of it like our alphabet, so A, B, C, D, E, and so on. We use these symbols here to write any word in the dictionary, and likewise we can use these symbols here to write any number conceivable. Okay, so that's why it's called decimal or denary. This is also called a base 10 system, and again the reason why this is called base 10 is because we have 10 symbols. So how does decimal work? Well, hopefully you'll be aware that we have columns in decimal. So if I were to write the number, let's say 372, what I would do is I would say, right, this is the ones column, or the units column, this is the tens column, this is the hundreds column. And the way we read this is by saying, this one is 3 times 100, plus 7 times 10, plus 2 times 1, and that gives us the number 372. I could rewrite all that and have a different number. Let's make it a little bit bigger. Let's have the number 5,964. So clearly I have another column here that now means thousands. So I can write out 5 times 1,000 plus 9 times 100 plus 6 times 10 plus 4 times 1. This is our logic in our number system. And there are some important lessons to learn here which will make a lot more sense for binary. So let me write these a lot bigger. So I could ask you the question, how do we generate these columns? And you may think that, well, I don't know, magic maybe? And it's actually incredibly simple. So the first question that I'm going to ask you is, how did I get from my first column to my second column? And some people might say, well, I've added 9. And technically you would be right, I have added 9 there. But then if I say, how did I get from 10 to 100, you might say, well, I've added 90. And if you say the same thing to the next one, well, I've added 9990, and so on. But this isn't accurate. This isn't actually what's happening. What's happening is far simpler. So to get from the ones column to the tens column, what I have done is I've multiplied by 10. And then you might be shocked to realize to get from the tens column to the hundreds column, I have also multiplied by 10. And then to get from hundreds to thousands, I have also multiplied by 10. And you might be seeing a pattern here. Every column I go along, I've multiplied by 10. And you may be thinking, well, why is this happening? This seems a little bit bizarre. Or maybe you haven't thought about it. And the reason why we multiply 10 is because I'm in a base 10 system. I have 10 symbols to work with, 0 to 9. That's why we multiply by 10 to get to the next column. And you may think, well, okay, so in a base 10 number system, so what? Why do I have to multiply by 10? Well, let's go through it very simply. So when we're writing our numbers in maths, I start with the number 0. And then I can have a 1, a 2, a 3, all the way up to 9. But as soon as I get to 9, I've got a problem. Because if you look at my number line up here, I've ran out of symbols after 9. So you say, oh dear, well, what can we do? Well, what we do is very easy. we take the 9 and we add 1 to it, which gives us 10 normally. And we say, right, well, I'm going to push a 1 into the next column along and write a 0 in my current column. So rather than my calculation being 10 in this one column, which we're not allowed to do, I have to push a 1 into the next one. How do I read this? Well, it's the same as saying 1 times 10 plus 0 times 1. That's how we read these numbers in our number system. So if I want to now have 11, I start adding up again. I go 1, 2, 3, 4, 5, and so on, all the way up to 9. But then I encounter the same problem and I say, well, I've run out of symbols for this particular column. So what do? Well, I write a 0 in that column and I pass 1 along. So 1 and 1 is now 2. And I have 2 times 10 plus 0 times 1. So it gives me the value 20. And that process carries on for all of the numbers. So let's say I've got 99 here. I say, well, I've run out of symbols in this column. So let's add 1 to it. That means I have 0 here, and I pass 1 along. Okay, and then the same process happens again. 9 plus 1 is 0, and I carry the 1. And then now I get 1 times 100 plus 0 times 10 plus 0 times 1. And that gives me the numeric value 100. Okay, now you all already know this. You probably don't think about it at all. But it's very important, and I'm going to show you now why that is an important concept. So let's actually talk about binary. So a binary is another number system, and bi is, I believe that's Greek, and it means 2. And just array means number system, so 2 number system. And what symbols do we have to work with in binary? Well, all number systems start with the value 0, all of them. And what happens is you count up a number of symbols that you have, including the 0. So if I have 2 numbers to work with in binary, I start at 0, which is my first symbol, and then I have 1, which is my second symbol. So these 2 symbols, 0 and 1, are what I use in binary. The binary system is called base 2, okay, because we've got 2 symbols to work with. I'll explain in a moment why binary is used in computing, but for now we're going to look at the maths behind binary and how it works. So let's take our denary example again, our decimal example. So in decimal I had the columns 1, 10, 100, 1000, and so on. And we said that to get to the next column you times by 10 in decimal. And we say, well, why did I times by 10? Well, it's because I've got 10 symbols. Again, I've got the numbers 0 to 9 to play with. Binary is a different animal. It's only got two numbers to work with. So in any number system that you can think of, we always start at the column 1. And then we say to ourselves, okay, how do I get to the next column? And we say, well, times it by how many numbers we have. So binary, we have 2 numbers to work with. So I multiply that column by 2. And that gives me my next column, which of course is 2. I then say, alright, what's my next column then? Well, I've got 2 symbols to work with, so I multiply the current column by 2. That gives me 4. And I do the same thing, 8. Do the same thing, 16. And so on, 32, 64, 128, and so on and so forth. This is the binary number system. It uses ones and zeros, and its columns are powers of 2. So every column, the next column along that is times 2 of the previous one. So to get from 2 to 4 we times by 2, and to get 4 to 2 this way we divide by 2. Now adding up in binary is not the same thing as decimal at all, because we have different numbers of symbols. However, the principles are the same. And of course I will show you the easiest method of working out binary numbers, but for now bear with me. So like decimal, we start at the number 0, and I write that in. So of course that is the same as 1 times 0, which is 0. If I want to write the number 1, I put a 1 in the ones column, and that's the same as saying 1 times 1, which is 1. But like decimal, when I get to the number 9, I say to myself, oh dear, I've run out of symbols. Well, we don't have to panic, because what we do is we say, oh, well, I'll write a 0 in that column, and I'll push 1 into the next column along. And I do that in binary. So what that means is, this is the same as saying 1 times 2 plus 0 times 1, which gives me the value 2. So this value in this box is the number 2 in binary. Let's do another one. Let's say, right, well, that's the number 2. How do I write 3? Well, because I had a 0 in that column, I change it to a 1, and now it's the value 3 in binary. And how do I work that out? Well, it's 2 times 1 plus 1 times 1, which gives me the value 3. And let's do one more before we move on. If I want to write the value 4, now we're getting a little bit tricky here, so I add 1 to 1, and because I don't have a number 2 to use, I have to have 0 there and carry the 1 along. Again, 0, carry the 1. So now I have the value 100. And that's the same as saying 1 times 4 plus 0 times 2 plus 0 times 1, which gives me 4 in total. Okay, now obviously you're looking at that right now, you'll be thinking, oh dear, I have no idea what is going on here, I don't know how you're doing this, etc. Please don't worry right now, because I will be showing you in a moment how to do this more simply. However, you just need to be aware of that to get to the next column in binary, we multiply by 2, and we only have 2 symbols to work with, 0 and 1. But let's take a step back and say, right, why does binary exist at all? And the reason binary exists is because computers use something called voltage, which you may have heard about in physics, and voltage in a computer goes usually between 0 volts to 5 volts. Okay, and this represents the zeros and ones inside of a computer, 0 and 1. And the reason why this also exists is because computers use something called switches. And hopefully we all know that a switch normally is either on or off. Apologies there. On or off. And if it's on, it's a value of 1, and if it's off, it's a value of 0. So early computers, electronic ones, used something called a switch, and they could be on or off. And you may have learned in the past about the CPU, the central processing unit, the brains inside of a computer, and it is made of billions and billions of these tiny, tiny switches that are on or off. And you can also think about binary as the electronic pulse of a computer. So maybe you've all seen heart monitors, you know, the kind of things that go boop, 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 stuff like that. You can think about that as very similar to binary, where the lows are zeros and the big boops are 1. So this would be like writing 0, 1, 0, 1, 0, 1, etc. Okay? That's why binary exists, because computers use switches in order to work. And if you end up doing GCSE, you'll be more aware of why that's the case and how they work. But for now, it's just important to know that things are on or off, which means it gives us a nice number system to work with, i.e. binary, because again, on is a 1 and off is a 0. So, what does this mean for you and today's lesson on calculating in binary? Well, I found maybe the simplest way of thinking about binary is imagine, or hopefully you can imagine, that you've used Lego before. Hopefully you've all used or at least seen Lego bricks. And we know that Lego bricks are literally a brick, like this. Apologies if the diagram's a bit rubbish. And those bricks have little studs on top, little circles. And the point of Lego is that you can stack these studs on top of each other and they fit nicely. What does that mean for us? Well, I'm going to draw some Lego bricks. So let's say here's one Lego brick, and this Lego brick has 8 studs, 8 circles. The next Lego brick I have has 4 studs, the next one has 2, and the last Lego stud has 1. Hopefully you'll have all seen these kinds of bricks. Now, in order to make this analogy work, please assume that you only have one brick of each. So, I'm a very horrible person, you're playing with Lego, and I've said, right, you're only allowed one of each brick. So you've only got one 8 stud brick, one 4 stud brick, one 2, and one 1 brick. Okay? How can we use this to help us with binary? Well, let's say that I wanted you to write the number 13 in binary. And we're using these Lego stud bricks. And we say, right, the little studs on them, the circles, represents the numbers that we're allowed to use. And because we only have one of each brick, that means we're very restricted in how we would write these numbers. So what I would do is, I would start at the top brick, the biggest one, and I would say, right, do I need this brick to help me make the number 13? So what I do is, I say, right, 13 minus 8 gives me 5. This brick, the big one with 8 studs, fits nicely into the number 13. So I say, yep, I'm going to need that brick there. And I subtract the 8 from 13, which leaves me with 5. So there are 5 bricks, 5 studs left to fill. And then I move on to the 4 brick and I say, right, does this brick fit nicely into 5? And I say, yes, it does. So I take that away and say, right, I'm going to use that brick. I now move on to the 2 brick and I say, does the 2 studs fit nicely into 1? And I say, well, no, it doesn't. It doesn't fit in there at all. So I can't use that brick to make the number 13. So I put a cross there and say I can't use that brick. Finally, I've got the 1 and I say, right, well, 1 does fit into 1, so I take that away and I'm left with 0. And I say, right, I can use that brick. And now, what I'm going to do is I'm going to add up all of these studs. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have just made the number 13 using these bricks. And why does this matter? Well, if you look at these ticks and crosses, you can change the ticks for a 1 and the crosses for a 0. So right now, my number in binary for 13, which is in decimal, so this is a decimal number, 13, that's how we write it. If I wanted to write it like a computer would, I would say 1, 1, 0, 1. This is how computers write the number 13. So when you're doing your calculator, like in maths, and you say, 13 plus 20 and times by 5 and so on, the computer doesn't see the number 13. The computer sees these binary strings, 1, 1, 0, 1. That's how they add up. And it can get quite long, obviously, because we've got less symbols to use. But let's try another one. And to save myself from writing all of those studs out, I'm going to change them for numbers instead. So here's a 1 stud, here's a 2 stud, here's a 4, an 8, a 16, a 32, and so on and so forth. Let's try writing the number, let's say 59, just for the sake of argument. And I start at the 32, and I say, right, okay, 59, take away 32, does that big brick there fit into my number? And I say, yes, it does. So I take 32 away, which gives me 27, and I put a 1 in the 32 column. So far, so good. I then move on to the 16 column with 16 studs on my brick. And I say, does 16 fit into 27? And I say, yes, it does. So I take 16 away from 27, which leaves me with the number 11. So I put a 1 in the 16 column. I move on to the 8 column now, and I say, does 8 fit into 11? And I say, yes, it does. So I take away 8, and I'm left with 3. So I put a 1 in the 8 column. I now move on to the 4, and I say, does 4 fit into 3? And no, it doesn't. So I write a 0 in that column to say it doesn't fit at all. I then move on to the 2, and I say, right, 3 take away 2, does that fit? Yes, it does. So I subtract it, as I've done there, and write a 1 in the 2's column. And then finally, I've got 1 left, so I say 1 minus 1 gives me 0, of course, and I write a 1 in the 1's column. So what we have just done there is we have written the number 59 which is decimal, into binary, which computers read as 111011. That is the number 59 in binary. And you can do this with any number that you want. So let's do one a little bit bigger, a little bit more exotic. Let's do 177. And you're thinking, oh dear, here we go. This is a big one. And you think, well, 32, the highest column we've done so far, it does fit, but if I add all ones in my columns there, I would only be able to reach the number 63. And you can test that out yourself to prove it, but just believe me on that for now. So what I need to do is I need to have a number of columns that allows me to get the maximum breadth of numbers, and that is 128. The reason why it's 128 is because if I double 128, I get the number 256, which does not fit into 177. Therefore, I don't need to write it, so I can just delete that one. And I use 128 because it does fit into 177. So starting from the top end, I say, right, 177 take away 128 gives me the value 49, I believe. Yeah, 49. So I say, right, 1 goes in the 128 column. Brill. I then move on to the 64, and I say, does 64 fit into 49? And I say, no it doesn't, so I can't use that column at all to make up my number. I then move on to 32, and of course 32 does fit into 49, which gives me 17 when I take it away. So I write the number 1 in the 32's column to say it does fit into 49. And of course I then move on to the 16's column, so I take 16 away from 17, which leaves me with 1. So I write a 1 in the 16's column to say I have used that Lego brick. Because remember, we only have 1 of each. I move on to the 8's column and I say, does 8 fit into 1? No, of course it doesn't. So I move on. Does 4 fit into 1? No, it doesn't, so I write another 0. And does 2 fit into 1? No, of course it doesn't, so I write another 0. Finally, we get to the 1's column, and we say, does 1 fit into 1? Well, yes, of course it does, so I take 1 away from 1, which leaves me with 0. And now I'm done. This 1 0 1 1 0 0 0 1 is how a computer would write the number 177. Okay? Remember that you're speaking a different language right now. You're speaking machine language, the language of every digital device you use today. This is how they write their code. So what we have done is we've been able to turn decimal or denary into binary using this method. But you might be thinking, well, how do I go from binary to decimal? How do I go the opposite way? And it's just as simple, so let's give that a try. What I'm going to do is I'm going to write out my columns again, and the safest thing you can do when you're working in binary is write all of your columns up to 128, because most things in computing uses 8 bits, which are called a byte. 8 bits are called a byte in computing, which is why you may have heard of stuff like kilobytes, megabytes, gigabytes, and so on. So if you're ever stuck and don't know how many columns to use, just use 8. It's always a safe bet. And what I'm going to do right now is write a random number. I have absolutely no idea what this number is right now, but we'll find out. So, what we're doing right now is we're going from binary to decimal. What do I do? Well, I have a look at all of my columns, and I add up all of the columns where there's a 1. So I don't have 128, so I don't do anything with that. But I do have a 64 column, so I write down 64. I also have a 32 column, so I also write 32. I have an 8 column, a 2 and a 1. And now I just add all of these up. So 4 plus 2 is 6, plus 8 is 14, plus 2 is 16, plus 1 is 17, so I write a 7 and carry a 1. 6 plus 3 plus 1 is 100, so I write a 0, sorry it's 10, but I write a 0 and carry the 1 to the next column. And 0 plus 1 is 1, therefore this number that I've randomly written down is the number 107 in decimal. Okay, let's do another example just to show you how it works again. So another random set of numbers. Let's do 1, 1, 1, 1, 1, 1, 1, 1. They're all ones. What kind of number will this make? Well, let's find out. So 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. What possible kind of number will this be? Well, let's add them up one by one. 8 and 4 is 12. 14, 20, 28, 32, 34, 35. So I write a 5 there and a 3 there. Let's add up the next one. 2, 8, 11, 12, 13, 14, 15. So it's another 5 and I have to carry a 1. And 1 plus 1 is 2. So if they're all 1s, the maximum number I can write using 8 columns is 255. Now that's a very interesting number, because if you remember earlier, every time you double a column it gets 2 times as big. So here's 64, 128. Our next column along is 256. And what number did we just write using all 1s? 255. And if you look carefully here, the next column along is always 1 bigger, should I say, than all the 1s in the columns before it. In other words, if you want to work out the maximum number in the current column number you have, so let's say, what's the maximum number up to 16, so 5 columns? Well, what's the next column along? It's 32, take away 1, therefore the maximum number you can write in 5 columns is the number 31. How can I prove that? 16 plus 8 plus 4 plus 2 plus 1 is 14, 18, 30, 31, 21, sorry. 2 plus 1 is 31. Okay, that's a bit of a side point, but it is very interesting. So in order to go from denary to binary, what you do is you write all your columns out, and one at a time, starting at the biggest column, you see which brick fits in. So you start at 128, then 64, then 32, and so on. If you're working the other way and you're doing binary to denary, what you do is you add up all the columns where there is a 1. And at the end of the day, that is the basics of binary that you would need to know for today's particular lesson. So I hope that has been helpful. Please give those worksheets a try. If you're having any problems, please leave a message in the It's Learning section and we'll do our best to help you. So thank you very much for watching, and I hope that was helpful.